Are we ready to go? We're okay? Okay. Adjeleian family, and we are fortunate to have here with us today all the two children and Dr. Osama Moselhi, distinguished guests, ladies and gentlemen. My name is Jack.
The other microphone we took earlier, where did you put it? Is it turned off? No, the other one, the one that he had. It's not?
Hello.
Hello.
Thank you. Thank you. Thank you. I hope that cheering was for me. My name is Jag Humar, and I have the privilege of being the master of ceremony or the host for this evening. Thank you for being present this evening as we celebrate the legacy of Dr. John Adjeleian in a manner that he would have admired through a lecture by a distinguished engineer, academic, and researcher. And we have with us none other than Dr. Osama Moselhi to fill that role. I will later have the opportunity to more fully introduce him. It is my great pleasure to now invite Ms. Banu, or my chief professor, chair of the Department of Civil and Environmental Engineering, to welcome you and to welcome our speaker on behalf of the department and the university. Banu.
Welcome to our in-person Adjeleian lecture, and it's such a pleasure to have you all here, our guests, professors, students, undergraduate and graduate students, colleagues. So during COVID, we did not take a break, but the events were all on Zoom, hybrid events. So this is really nice to have you in person here, and it's a celebration event as well. We have a wonderful speaker, but this is also the time where we do our award ceremony for students. And it's really nice to see all of you to come together as the civil and environmental engineering family together with our guests and donors. And it is an honor to host you here today. So we have an amazing speaker. This organization of this event has been a lot of work. Thanks to Ehad, Jag, Reynolds, lots of people are involved. And I'm really looking forward to the talk and also to the award ceremony afterwards. And in the end, we have some refreshments for you. So please stay around. Thank you.
As I said earlier, this lecture series was commenced in the year 2003. Is our way of celebrating the legacy of Dr. John Atalian. You see him here. I had the privilege of knowing John and collaborating and working along with him from 1975 until he passed away in 2004. John was the rare person who combined the qualities of intellect, creativity, leadership, humility, compassion, and kindness. He touched the hearts and minds of many,
and those of us who knew him were blessed in many ways. This is the 20th
year we are holding this lecture.
Each
Each
year, I
year,
get
I
the
get the
privilege of
privilege of
speaking
speaking
about
about
John's
John's
legacy
legacy
and the
and the
contributions he made to
contributions he
his
made to his
profession
profession
and to the
and to the
society.
society.
And it
And
fills
it
me
fills
with a
me with a
sense of
sense of
awe,
awe,
but
but
also
also
of
of
pride.
pride.
After
After
earning a
earning a
bachelor's
bachelor's
degree in
degree in
civil
civil
engineering in
engineering in
1982 from
1982 from
McGill,
McGill,
John went
John
to
went to
United
United
States to
States to
earn an
earn an
MASc
MASc
in
in
structural
structural
engineering
engineering
from
from
MIT
MIT
in
in
1955.
1955.
John
John
returned to
returned to
Canada
Canada
that
that
year
year
and set
and
up a
set up a
structural
structural
consulting firm
consulting
in
firm in
Ottawa.
Ottawa.
His
His
firm
firm
quickly
quickly
established a
established a
reputation in the
reputation in the
city and
city and
outside,
outside.
and the
And the
firm's
firm's
name was
name was
Adjeleian
Adjeleian,
Allen
Allen, and
Rubelli.
Moselhi.
The firm
The firm
continues to
continues to
thrive
thrive
with
and
offices in both Ottawa and Toronto. Over the years, it has provided structural consultancy for a large number of diverse structures, some much which became recognized as outstanding examples of architectural and structural innovation. They included the Fathers of Confederation building in Charlottetown, the National Arts Center in Ottawa, the Aviation Museum in Ottawa, the Sky Dome in Toronto. The structures that John was most proud of, these were the structures that he was, there are many more structures, but these are the ones he was really proud of. And I had the pleasure of working with him, at least on two, Aviation Museum, the Sky Dome in Toronto, as well as the Arts Center. John's firm also designed a majority of buildings on this campus, starting from the oldest one, the Tory building, to the very recent one, the Canal building. His firm designed these buildings, a number of them. John joined the then Department of Civil Engineering at Carleton University in 1975. He served as the chair of the department from 1976 until 1982, when he took retirement and was appointed emeritus professor. During his tenure as chair, he established the department as a center of excellence in teaching and research in the field of engineering. And since then, the department has taken great strides in these areas. You will later hear about that. John was a visionary with a unique ability to visualize how a structural form will work in harmony with the architecture of the building, a rare quality that not many engineers possess. He encouraged teamwork that brought engineers and architects together. In fact, he was that rare engineer who was admired and loved by the community of architects. And if you are either an architect or an engineer, you will know what I mean. Of the many honors received, John was proudest of his honorary membership in the Ontario Association. The John Adjeleian Lecture has been established to celebrate the standard of excellence exemplified by John. Lectures in the series highlight the outstanding achievements in professional practice, education, and research that have advanced the field of civil engineering. It is our way of celebrating the professional achievements of John. Our speaker this evening, Dr. Osama Moselhi, Professor and Director of the Center for Innovation and Environmental Engineering at Concordia University, eminently fulfills that role. And we are indeed privileged to have him speak to us. I will introduce Dr. Moselhi more formally little later on. Maybe do that now. Dr. Moselhi is Professor and Director of the Center for Innovation in Construction and Infrastructure Engineering and Management, Department of Building, Civil and Environmental Engineering at Concordia University. He is a fellow of the Association for Advancement in Cost Engineering, the International Society of Civil Engineering, the Canadian Society for Civil Engineering, and of the Canadian Academy for Engineering. His research interest encompasses two major areas: value-driven asset management for sustainable and resilient civil infrastructure, and optimized delivery of engineering procurement and construction projects. His industry experience spans tall buildings, bridges, nuclear power plants, harbors, and offshore facilities. Dr. Moselhi supervised and co-supervised the completion over 100 master's and PhD graduates and has authored or co-authored over 400 scientific publications. And above all, Dr. Moselhi is a member of the Order of Canada the highest civilian award that the nation gives out, a distinction that adds to his list of accolades and awards that include the Walter Shanley Award from CSC, the Tucker Hasegawa Award from IIARC, and the Brian D. Dunfield Award from the AACEI, and the list goes on. Now I want to welcome Dr. Moselhi to the podium to deliver the lecture.
Don't worry. Yeah, it is working. Thank you, Jack, for the kind introduction. And first of all, thank you, Ahab, for the gracious invitation to come here to your department and to Carleton University and for the hospitality. Thank you, the chair of the department, for the kind words in the early going. Are we ready? Okay. I could say a story until we get ready. Frankly, I had wanted you to give me the allowance to give you a story of my academic and professional journey. The journey is long, so bear with me. It is more than 50 years, but I will squeeze it. Considering time, how about we're going to do every 10 years in 1 minute. Would that go? Okay, this is what I'm going to, every 10 years, squeezed in 1 minute. Ready? Yeah. And I also use because I want to hit certain things, will I be able to use also that? Excellent. I'm in good shape and in good hands. Thank you so much. So the journey starts right here at the cursor is, we're going to get there. Don't worry. So I wanted to get the cursor on at this point. You see, it's moving fast. Right there. It starts all here at Cairo University, where in 1970 I earned my degree in bachelor degree in civil engineering, and I really had a remarkable opportunity to work in the most esteemed consulting engineering office in the country at that time of Professor Mohammed Hilal, where I had the opportunity to design and participate in design of a number of reinforced concrete structures below ground and above ground. And then in pursuing further graduate studies, I moved west to Canada, all the way to St. John's, Newfoundland. And believe you me, that was my first experience with snow. I worked under the supervision of Professor D.V. Reddy in the area of finite element analysis of dynamic soil structure interaction with some emphasis on underground nuclear plants. Remember, that was the mid-70s. I think some of you maybe have witnessed that era with too much talking about tall building structures. I hope that some of you would remember the name Fazlur Rahman Khan. Did any of you remember that name? This is the fellow that designed the Sears Tower in Chicago, the tallest building at the time. Just an amazing guy. And also John Hancock Building in Chicago and many landmark tall buildings. But this fellow introduced a postulate, something without a proof. He said, well, for tall building frame structures of 100-story tall, you don't need to analyze that 100 stories. All what you have to do is analyze only 10 stories of an equivalent structure. And this is by tweaking some of the properties of beams and columns, you're going to get the equivalent structure. And why doing all of that? Analysis of tall building frames will be quite expensive. Imagine at each node, even if you are talking about only 2D, you have 3 degrees of freedom for those who are doing structures. Imagine that was very costly affairs, not now, at that time. So people were going for approximate solutions that would yield reasonable results, good enough for design. So, but really reducing something 100 to 10, that for me as a grad student doing my PhD was very intriguing. Why 10? Why not 8, 7, or even 5? I asked the questions and I did not get an answer. So I figured out I have to figure out the answer. And believe you me, by the end, I really proved theoretically the conditions of equivalence and exactly what properties you should change and play around in the beams and columns in order to get the equivalent frame, and also establish the relationship between the accuracy and the number of floors in the equivalent structure. So why not 10 or 8 or 7? The answer was there. This will lead accuracy of so much. That will lead to accuracy of so much. With that story, but so we've done this by moving into, I wanted to hit something more. Yep. This was done in when I was at Concordia doing tall building, because my Dr. D.B. Reddy at the time, I was speaking with him about tall building. He said, well, Concordia University establishing a building engineering program. And Dr. Paul Fazio is leading that. Very quickly, I contacted Professor Fazio, and soon I was working under his supervision in tall building analysis frame structures. And that was at Concordia on tall buildings. And this was the building when I came to Concordia at that time. They have more advanced buildings these days. This is the type of thing I worked on. And not only there. After I finished 1 month up with eight. Yes, okay. So at that time also, before even finishing 1 month of my postdoctoral fellowship, I was given an opportunity to work as a senior engineer at Keynote. And for 4 years, I worked in that company in Montreal for the analysis and design of the CANDO system, the 600 megawatt reactors, and I had the opportunity to work on Wilson 1. This was the first unit. The site allows for 4 reactors, but first unit, and also Cernavoda in Romania, and limited work in Pickering in Ontario, and as well in Pointe-la-Pro in as well. That was the kind of field, but the story did not stop there. I moved, believe it or not, way back east to Saudi Arabia, to the city of Jubail, where I assumed the role of advisor to Saudi port authorities on the construction of management of the commercial port of Jubail. We're looking at quay walls, we're looking at breakwaters, quay walls, and many control towers, facilities underground, above ground. That was for 3 years. And that particular opportunity and that role really provided me with a invaluable insight into large-scale construction projects. And also, in addition to the construction, there was a wide range of engineering practices that from all countries of Europe, each is designing a piece or having that particular, and they did not have their own codes. So if you hire a consultant from the UK, they were using something in the UK. From the USA, they're using something, and so on. So that also gave me a perspective on global engineering practices. Well, I must say the pay was very good. Okay. Yeah, but I had to go. I had a mission in mind. So I always said, well, that is enough for that for 2 main reasons: family, and then my love affair. I was telling Bora, who kindly gave me a lift to the campus here. I have a love affair with academia, and I wanted to work as a faculty member and impact the life of young students and stuff like that. So we've moved back, guess where? Montreal, and guess where? Concord, but this time as a faculty member, where I worked in the area of construction, engineering, and management. And again, that was a remarkable opportunity, really, to impact knowledge and also to mentor, uh, really generations of aspiring engineers. I think we should pride ourselves, all of us, as in the academia, that we have a clear impact on the generations of engineers. So that was an excellent opportunity for me to work in that field and also to contribute to the landscape of civil engineering. So this is where I went back from Jubail all the way to Montreal. And now I stand before you trying to reflect on the many experiences and the, I would say, rich tapestry of knowledge that shaped my journey. And let us start with that dynamic landscape of civil engineering. And here I have on our agenda a number of things, but they are all, I have three main topics today. They are interrelated, and they interrelated because of the challenge. So we have a wide range of challenges. This is not an exhaustive list. So we have environmental, we have a role to play here as civil engineers and environment, and also in safety during construction, safety during the operation of various facilities, and if you're familiar with that, and then productivity and competitiveness. We've got to stay in the business. If we're not competitive enough, we're not going to find jobs, we're not going to work, we're not going to make an impact. So the idea here is really to stay, and for our own sustainability, we look into productivity, we look into competitiveness, and again, for whatever we build is civil infrastructures, bridges, tunnels, water distribution networks, all of this stuff, they're going to be issues of sustainability and resilience. And toward the end, I will share with you what do you mean by resilience and how can we measure resilience? People talking about it. Can you measure it? Do you have a thermometer to say 90% resilient or 50% resilient? This is what we're going to take a look at. And as I said, we have three main topics. This list of challenges really link the three topics. The first one is almost with history. How a project are conceived and delivered. I mean, you have an architects, you have engineers, you have sub-trades, subcontractors, material suppliers. What happened? So we're going to take a look at from ancient time. No, I just wanted to say a few things here. I'm going to acknowledge, I really pride myself by really having worked with way above 100 master's and PhD students. But I am going to cite their names in many of the slides to follow in this lecture. But those who their work is not appearing today, but did help me in the front end, Shuru Gharib and also Abdelhadi Omar, they're two PhD students at the moment, and they did help me with the front end and the animation that you have seen. So thank you for them. Starting with the first topic, and we said we're going to take a look at how projects are conceived and delivered. And again, from ancient times, and being of Egyptian origin myself, I've got to put the pyramids in there and the ancient Egyptian temples. And then, of course, nothing beats what you see in Italy and the Roman Empire times. And these are plantings. They're beautiful as they are, again, but if we look even further, and just before the industrial, you see the vertical, there is a vertical line there, the Industrial Revolution. Before all that, in the Renaissance era, you would see a fellow like, I think you know, Leonardo da Vinci. Well, this is the fellow that had it all. So he was an architect, an engineer, and a painter, and sculptor. I mean, he had everything. He knows the material. So he was able then to deliver, have all the functions needed to deliver a facilities like that. Look, so the era of the master builders, someone like the categories of Da Vinci, they would know it all. So they don't need to hire and separate an architect from the engineer, no, it's all in one. And I think by the advancements and with the challenges that we faced, because number one, of the complexity of the projects. The second thing, the advancements in technology and science, then this gave rise to specialization. So no longer we have everyone that knows everything. If someone will tell you, I know everything, you know that he is not a good guy, right? Yeah. Yes. So we have to split, and we split our pieces together. From even design is not good enough. Various, we split that into HVAC design. Firms are specialized in that, architectural design, structural design. So even that, the question is, don't forget, we wanted to go back to the project. We wanted to go back here. How can we do that? The construction management approach was introduced in order to organize these people together, and all of these will come into with one focus on the project, deliver with the project with the targeted objective. So that was the whole idea of behind construction management, and a series of project delivery methods, how we deliver this project and how we deliver. It's almost like delivering a baby. At least we know how we deliver a baby, but for projects, you need more than that. So there are key participants that can deliver that kind of thing. In the original stuff, this is the traditional design bid build, where the owner would have a contract with the architect, then finish the work, they bid the job, and then, okay, we're gonna select the most qualified bidder, the contractor, to do the work. Notes here that the contracts are always between two parties. So the owner would have a contract with the architect. That's it. But the owner will have a contract with, right. So the contract always have party A and party, the first party and the second party, no more than that. But then by introducing construction management here, and also this is what, CM at risk. At risk, it means the construction manager is maybe guaranteeing the maximum price of the delivery and is taking that risk. And you need to levels of integration because he put his money there and wanted to make sure that things are well coordinated. For integrated project delivery, they're all integrated. So it means in that case, there is at least the contract will have more than 3 people. And then the focus will be on there. They open their books, they sharing risk. There is a lot of things in that. But again, it's not a panacea. Every project, and again, all of these project delivery methods are really trying to achieve all of the above. It all depends. I wanted to have more focus on how long the project will take to deliver. So are we looking at time in the beginning? Are we looking at the cost? Are we looking at risk sharing? Are we looking at an environment where we can create to improve and advance innovation? That could also, a certain project delivery methods will allow you to do that. And then if we have a need for work, contractors have a need for work. So, but there is no jobs around, what can we do? And this is the story of behind the PPP, or the P3s, they call them. Public-private partnerships. So a contractor who wanted to work and he have his staff ready, technology ready, sometimes equipment ready, and an owner who wanted a facility, but he doesn't have the cash. Okay, we're gonna get into agreement, and I'm gonna build it for you, but I'm gonna ask you to pay for the services later on. So this is the kind of, one of the good examples of a PPP with the Suez Canal in Egypt. Very back, okay? But then in modern history with a prime minister of Italy, of Turkey at the time, Ozal. This fellow introduced the modern PPPs, and we're able with that partnerships to build a lot of facilities. Of course, later on, China was, for the big part, a lot of projects were developed and produced on that PPP arrangement. In Canada, we have a good experience with that. And I can move from that slide. So the project delivery methods then are delivered in order to give us a vehicle that would coordinate these stakeholders of the project and let us go back and focus on the project after that fragmentation, and while benefiting from the advances in science and technology. So all of these were developed in order to have this fragmentation back to the time of master builders in that project, okay? Even there are other factors I did not list there. The kind of service. There are sometimes core services and non-core services in the PPP arrangements. So for example, the first model is design, build, finance, and manage. The other one, the same thing, design, build, finance, but operate. The Canadians would not like to have their hospitals operate in the private sector. They don't like the prisons to be operated by the private sector. So in this, but that could change. So this is a country dependent. In the US, they may accept that. And actually the prisons, they accept that. So the question here of public acceptance and what public wants in order to deliver such a thing. Okay, moving forward. With that complexity, organizations such as, this is by the way, a very interesting organization, the CII, the Construction Industry Institute in the US, developed this, an automated system. Give me the characteristics of the project. I will tell you what is the most suitable project delivery method for it. It's a simple spreadsheet application, but it did not have all the other advanced, including even integrated project delivery. So a former student of mine, she was an architect originally, and expanded that work to include others and also give a guidance. There are more specialized work, for example, in airports, how to, again, so in search for the project delivery method that would be ideal to help us integrate these beautiful resources in order to come up with a project that would satisfy its targeted objectives. That was the whole key issue there. The second topic on our lecture today. What are we doing with the zero net carbon emissions that Canada committed itself by the year 2050? This is what we have. And believe you me, even we should be reducing the emissions at the levels of 2005 by 50% in the year 2030. It's almost tomorrow. What are we doing? I'll share with you what is happening, and I'm happy to share it frankly with you. And here it is. NRC here in your beautiful state, beautiful city, Ottawa, have introduced a platform, NRC platform for decarbonization of the construction industry. And this was done in what? In May 2023, just last summer. Yeah? And again, there is a lot of money for research and for people to team up in order to help address that carbon emissions and the reduction and meeting these targeted objectives. So we've teamed up with colleagues at Concordia and other universities in Canada, and also partnered with individuals in NRC. And at the moment, our projects have been adjudicated and approved, and soon they will be, soon, next month, right away, soon they will start working on these issues. The beauty also that this come at a time where also Concordia University was ahead of NRC, 1 month. So this is what we've done. At Concordia University, really received a historic fund from the federal government of $123 million, another 25 from the province of Quebec, and also to address the same thing, the decarbonization. And this fund from the federal government came from the Canadian First Research Excellence Fund, okay? So what happens, we have projects at Concordia, and we double as much the money from as well NRC, and some of these projects are already evaluated at both sites, in Concordia and some of them are completely supported by NRC, not Concordia, but some are teaming up in order to maximize the resources and moving forward with that. So this is what is happening. And in the strategies of all these efforts, there are 3 main strategies: carbon-less material, modular construction, or what we call it industrialized construction, and circular economy. So I'm gonna touch base on every and each very quickly. So looking at carbon concrete, how can we do civil engineering without concrete? I mean, it's everywhere. It was helpful to us in really building and shaping many of the facilities that we enjoy today. But a closer look at this, look at what is happening here. Although cement is almost constituting about 12% by volume of the whole mix of concrete, it contributes to more than 80% of that carbon emissions. So the solution was right away, and the focus would have to be clear. We've got to produce cement that is carbonless. And also Canada to take a lead, because also we export things to the US in concrete and concrete products. So that would be a great thing to do. And I was happy to see this document already in Innovation Science and Economic Development Canada. as you know, we have over 1,000 plants for ready-mix concrete and production of cement blocks and even precast units. And they contribute sizably to our economy, about 76 billion. So that is a good sector, but then we need to reduce the carbon by having less carbon cement and then becoming pioneers worldwide and also sell to our neighbors south of the borders, and that will be a good business and a good environment. The second part, modular and industrialized construction. In modular, you really fabricate the built facilities in the factory, be it in a volume. Maybe if it is a simple house, the whole house could be built in the factory and shipped to the job site, okay? But if it is not, then we have to have maybe floors and sections and large modules, and then we transport that from the factory environment to the job site. And on job site, we do the assembly and the construction operations. Of course, in between will be transportation. But there is a lot of work that has to be done and continue to be done. And this is an invitation for research in all of these fields. For example, in what we're doing in modular construction, Angat Bahatia is a PhD student and is working on optimizing the floor plan, the production line. If you have a facility, and he's really visiting that facility from Alberta and Edmonton, and these are fabricated wood panels, okay? So what he's looking at, if you are the manager of this production facilities and you have contracts from different projects with signed dates to deliver these series of panels by a certain date, how can you optimize that with one focus on idle time at each processing station here, like in framing or shearing or nailing or, you know, all of this? You need to have least idle time at each of those machines in order to be as efficient and also profitable. Remember, the productivity, very important for us, and competitiveness. We need to stay in the business by being competitive. So he's doing that kind of work. But other work could be done in how we automate the process, how to capture the data, and a lot of good work can be done by this. Actually, with looking, I don't know, I don't want to spend, someone have to control me and my time because frankly, I could go in stories. But in the outdoor or on the job sites, again, Tariq Salama is a PhD now, he's a faculty member in California, and he's looking on the optimize what we produce in the factory all the way and synchronize it what would happen on the job site. And he's using last planner system, linear scheduling methods, and many others, and to optimize them. All of these are, if you Google their names, there are a lot of publications in these fields. But the idea here is that we need to do certain works in the factory and also on the job site. And in between, another fellow, Mushtaba. Mushtaba did a really remarkable piece, and we didn't know if it will work or not. We would want to do transportation of these components and modules from the factory to the job site. That could be 400 kilometers. It could be a long story. I remember in one of the largest hospital in Montreal was recently built. There were modules shipped from Florida all the way up to Montreal. Imagine what can happen on the road. How would we know that the module is not damaged? That was a question. So Mushtaba did something very interesting. We worked with him. Have a sensors, mainly accelerometers. So we could capture acceleration in a certain locations fitted on these modules. And then we do some kind of unsupervised clustering techniques to identify and tell you if this is likely to have a defect or not. And the chances are this may not have a defect. So again, there's a lot of work that can be done on the 3 stages as well. Moving along with the circular economy. The circular economy, unlike what we do in the linear, where we make or we take whatever materials and whatever, and we make buildings and facilities, and then we dispose, and we have a lot of garbage. And maybe toward the end of this presentation, it is alarming the amount of garbage disposal that we generate, and also our need for further material and resources. It would be astonishing, really. This would be a real drive for circular economy, where we have to really have a fresh look at design. Design for disassembly, design for adaptability and flexibility. The more we extend the life cycle of the built facility, the more we don't need another one to build. We don't have to spend energy to build a new one. So that would be the kind of saving and in that respect. And here, as you would see it in the literature everywhere, the 3 Rs. They're talking about reduce, reuse, and recycle. One example, for example, here, the waste. I told you that. And this is just taking it from the World Wide Web. At the year we wanted to eliminate carbon emission, remember that was 2050, correct? Here is the projection. We will anyway, global waste generated will be extended by about 70%. Not only that, and our consumption would require 3 planet Earth with wanted resources from 3 Earths. I think this is an invitation right away to have to rethink seriously how we do things, and particularly rethinking, and that really will be an invitation for us in civil engineering to relook at the curriculum and what we wanted to do in order to support circular economy and its principles. One good example for reuse, if you watch the World Game, the World Cup in Qatar, which I did. I like games, I like to watch stuff, okay, including hockey and all games. Yeah, it's very interesting. But this particular one, this particular stadium, and I'm just quoting the BBC Sports here, was built to disappear after the games. In other words, it was disassembled, and some of the components were donated to other countries for their reuse. So that is a good example of that. Again, the problem really, I have to be honest with you here, in the circular economy, we did not find the business model whereby I can make money. But we have to invest in the future. There will come a point, but making money is not there yet. But we have to be able to think. And also the Canadian Standard Association also introduced an excellent document here on rounding the corners. It's all about circular economy. I think you're a great audience. You bear with me. We are in the third topic, but it's a little bit long. The third topic is about automation and digitalization, or digitization, or digital transformation of our construction industry. Okay, let us take a look at what I have here for you. And again, if you have any control on time, just let me know. I could wrap up, I could reduce, and whatever you see fit, because we could allow for questions and discussions. Always make things a little bit better. So here is where I see Deloitte is, if you look at the curves here on this left-hand side, the dark green and the light green, we are here, and the light green, and we are civil engineering and all of that construction thing. The manufacturing, the people in mechanical engineering are way up there, 1.5 times their productivity improvement and growth. So we need to catch up. So that was a drive for the digital transformation, which they have done, Industry 4, and now, talking beyond Industry 4, and we wanted these principles, we wanted to have them in our construction, in civil engineering. If you look at nationwide here, we're almost experiencing cost overrun of about 16% in most projects, and 90% of the projects are experiencing cost overrun. 90% of the projects are experiencing cost overrun. And for larger projects, they're talking about schedule delays of more than 20%, and this is very modest. I'm looking now at some of the, particularly in the field of mining and others and consulting work, and they're talking about several, maybe 80% extension, more than that, and 100 and something percent extension of time. Look, the industry is begging for a change, and a positive change. And that can happen through, at least from these points of view, through the digital transformation. Again, a little bit of tweaking our productivity on the global side. would contribute to a saving of about $1.6 trillion, and then saving our government time. And look at here is what they have: cost overruns of 80% in infrastructure projects, oil and gas and stuff like that. Now, I think we need to catch up, right? And this is an invitation for all of you here. Yeah, so that would be, we need to catch up. So also the labor force, the US Bureau of Statistics, they were looking at shortage by the year this publication was out, 2019. They're looking at 1/3 jobs vacant in construction. And by the year 2026, they're looking at 750,000 jobs are in need. So we really have to do something. It's not only about the number, also about the training and the skills that these will acquire. So we need really, and this is why, if you ask me, my former students, when they finish their PhD, no contractor will hire a PhD graduate. But now, a lot of contractors are hiring the new graduate PhDs now because they need to catch up with laser scanning, LIDAR, robotics, automation, integration, optimization. So this is happening as we speak. So, and of course, unfortunately, most of them go work with contractors because of the pay. The pay is a little bit higher than in academia. But again, you cannot win them over. Very good. Again, this is another study, also by Deloitte, and it really cites that in all project phases, look at design, finance, and procurement, in construction, in operation and asset management, in retiring the facility and decommissioning it. Yeah, that we will gain by the digital transformation. The gain, for example, they said in design, finance, and procurement, from 10 to 30% of the man hours, engineering man hours could be reduced. And construction, this is sizable. 5 to 10% cost of construction is sizable saving. And as you can see in operation and also in decommissioning, we always, like us, we need to retire. Also, facilities need to retire. But also, when dismantling it, it's not an easy job. And particularly for nuclear power plants, which now they're exceeded the life cycle of 50 years, they need to dismantle that. It's not an easy job, okay? In order to build on that and support the digital transformation, we've got to have a clear definitions. So we could all share them and build on them. But I could see in the literature, digitization is used interchangeably with digitalization. And also you may say, what's the difference? Okay, in a minute. Okay, here it is. In digitization, you could produce blueprints by AutoCAD in a digital form, right? You could produce your cost estimates in an Excel sheet. That's fine. In digital form. You could put your specs in a Word document, and that is a digital form. But the minute you start creating BIM, building information modeling, and transfer your design into that, and add to, BIM is considered to be 3D. Add one dimension, for example, integrate it with a schedule, and I will show you in an animated fashion. You could even see how things are going. How's time? Are we speed up? Cut? No? Okay. Very good. So that is the kind of thing. But as to digitalization, to me, digitalization is about value creation. We've got to create value. What do you mean by creating value? Yes, we're going to look into competitiveness. We've got to survive in the market, and we'll be better, and we could pay our people more. And this is how it could happen. Cumulative learning from one experience of, the wealth of many organizations, people consider it is the know-how of the people they work in that organization. But these people retire, and we don't capture their knowledge and experience on various projects. So that is the kind of digital transformation or digitalization that will help us do that added value or create value to control schedule and cost, and also labor in productivity and safety. But we're lucky. We have a lot of tools to use in order to create that value. We have a lot of technologies here. From enabling sensing technology, and we'll give you some examples of that whenever you have the time, and we could cut that. Scanning, from LIDAR, 3D laser scanning, and digital imaging, AI and data analytics, simulation, visualization, cloud computing, and Internet of Things. We've had a lot, and you could have various integration models and optimization models that you could use. So in creating these values, we can utilize some or more of these technologies, although this is not an exhaustive list. We could do that in tracking and progress reporting and construction in a timely manner, so we avoid the delays and related cost overruns. We could do a lot of things in productivity and safety, and in procurement and the supply chain and related risk in the supply chain. Communications among the stakeholders. Remember, the stakeholders that wanted to go to the master builders, they need to communicate. There has to be platforms for them to facilitate that communications, reduce time and cost, and also address the labor shortage. Yeah, and that is very important. And that needs to be done not only in one cycle, in all project life cycle, from design, construction, operation and maintenance, retirement, regardless of the project delivery system, design with built or integrated or CM at risk. And in that, we need to, a number of things. We do generate data and capture data from construction job sites, and then cluster these data and organize them and save them in such a way. And then data analytics, make something actionable out of this, meaningful, that the project managers can act on it right away as they see it. To me, this would require two essential processes. Two essential processes. Automation, and in here I'm talking about software automation and hardware automation. Robotics, a lot of AI technology and software. And in that, I wanted to be able, in an automatic thing, I'll show you maybe images of how could we do that. How could I recognize an object on this room? This is the project. This is a vent for the HVAC system, in a very smart way. So we have artificial intelligence techniques that we apply, image and analysis in a very smart way, and we could analyze them. But also we need to know where they are. So we need, after we localization, it means I know their XY coordinates automatically. Well, if I know what this is, and I know their coordinates, this is a great thing for a lot of applications later on. Visualization, also to speed up decision-making, all of that is very nice. Integration is happening naturally to us at the moment with BIM, and also with a number of digital platforms that people can use today in the market to integrate all of that effort. So integration is very important, automation is very important. A sample of what we have used. This is part of what we have in the construction automation lab at Concordia, where and our students have used it, from RFID, drones. But the very interesting thing, one of the students, Magdi Omar, developed that himself, customized sensing technologies. What do you want to capture from the job site? You wanted to capture acceleration, weather conditions. What do you want? Speed, for example, if a truck is moving in a certain direction, what do you want? I will design this for you. The beauty of he was not only civil engineer, he had a training in electrical and mechanical. And this is why I invite some of our faculty members in civil, integrate other disciplines. They bring added value, they have other ideas and concepts. And we've used that. I'm not going to talk about it. I know time is, it has the basic components are displayed in a GPS component. If you something beautiful, sensor-aided GPS. You know that GPS can help us identify location. But if you guide it with sensors, it could have much higher accuracy. And this could be a much better thing, and he did that kind of thing. And a lot of examples, I will share it with you in the next slide, about the various applications in digital imaging, be it in inspection, during construction, in operation and maintenance, and we will go through all of these just an image at a time. And again, just a reminder, during the design phase, I said, we're going to produce BIM. And the lucky and the good thing, and I will show you maybe at the last slide, toward the end of that presentation, in a survey happened, most of the companies are using it now. It's almost like anything else that this is a normal thing, a normal practice, nothing fancy, okay? And in bidding, this is what is happening in the province of Quebec. in the bid depository system. Everything is digital, automated from submission, drawings, evaluations, receiving who's the winner, sending the letters automatically to the architects, to the owner. All of that is automated. So again, the digital world is really upon us in all facets. This is the work of Samir Al-Omari, PhDs. All of these are, Samir is a professor now, somebody, I think in medicine in the US. But he did this early work. He among the first people that did with me the 3D laser scanning, what we call it LIDAR, but with photogrammetry. And then we were estimating the rock excavation materials in this building. Then this is the John Molson School for Business, downtown Montreal. Was built when he was doing his PhD, so we used that as a laboratory. So he was able to estimate the quantities, compare it with what the contractor have done. It was a generally good agreement. Of course, he published his work, and it was a great thing. So I wanted to say we're using all of these digital transformation and digitalization in various stages of the project. Now in construction, and later I'm going to give you examples in operation and maintenance as well. So again, in construction, this is Ali Muntasser, whose work, and this fellow was work after that in Bechtel and other organization. Now I think probably become an owner, or he has an eye on business. He doesn't want to go into academia or anything. He started with the BIM, and then, and this building, this was happened to a newly built facilities on Loyola campus at Concordia University. We use it also as a test bed for the technology that was prepared. So we integrated the BIM model, the 3D BIM model, with the schedule to generate the 4D. And by the way, he'd written a procedure for people. How can you do that? Because you don't have to go as a very fancy and very expensive software, a procedure very simple that you could apply. And from there, also using RFID, radio frequency identification, you'll be able to identify the position. You have a tablet, you put what you have seen, all of that would be integrated and automatically produced to generate a progress report using the earned value. If you're not in construction, you don't maybe know what earned value is, but we tried to get scheduled performance index, cost performance index, in order to know how are we doing as the project progresses. So we've used all of that technology in that case. Yeah, we flip into, yeah, remember that 7.5 by 6 and by 5.5, this thing that Magdi Omar customized, and this you can put it in your hand. And if you put it beside the driver of a truck, and we've used that in a major facilities downtown Montreal in excavation, we'll be able to produce productivity in near real time and know from the excavation site all the way to the dump site what is happening in between. If the driver is, you know, having a coffee and donut somewhere, or he have an idle equipment, or the equipment broken, we know. So the manager would know exactly on your laptop and that was used for earth moving operation by more than one student, actually, former students. This is a very interesting piece of work. This is the work of Farzana Garfo. Garfo, she used digital imaging and AI in order to identify objects on construction job sites. That work, when she was working with Pomerlo is the largest general contractor in Quebec, and on one of the largest, if they claim it is the largest hospital maybe in North America, I don't know about that, but I read somewhere. And anyways, it's a very large hospital. It's a Shom mega hospital, okay? And they were looking at the duct work, and she was be able to utilize AI technologies and digital imaging to track and identify objects, annotate them, and identify them, and be able to do progress. Another student, Dina Shamsullah, she did something very interesting, picked up from Farzana and added other interesting experiments with machine learning and from the literature as opposed to deep learning and what can work better for that environment, and utilize something like that in order to feed it image. And because we have shortage of images, she was very smart to generate what we call it synthetic images, not real, from BIM models, and integrate actual images with BIM, with synthetic images that we said 50-50 or 70-30, or she looked at various variations, what would be the optimum in order to utilize those actual images and the synthetic ones, and train the model in order to be able to identify objects, even in a mechanical rooms like that, where an object over time has object fighting, maybe cable trees, electrical wires. So we're able to have a success rate with that. Digital twin applications, you may have heard about that. And this is the work of Hassan Bardare. He's working with Pomerlo at the moment. And his work is about to finish. He did not finish his PhD yet, but his work was really, all of these technologies that we talked about early on, the RFIDs, radio frequency identification, ultra wideband, and I have it here listed. Where is the list of those? Not listed here, no. Anyways, and also they have a QR for RFID tags to put during the inspection. Fine, I identify that this is the projector. But is this projector defective or not defective? That RFID will help us analyze. And then the 3D laser scanning part, mobile, and utilize a wide range of technology. Developed actually in the construction automation lab as a test, and then later on with Pomerlo on a mechanical room with piping, equipment, the reservoirs, and we're able to generate that kind of useful thing. So again, and digital twin also going to have a great future moving forward in various applications. This is an old part. This fellow is maybe a senior professor by now in California, and he was among the first to work. When I told him, let us experiment with that, he thought that he was a very kind and very polite fellow. He doesn't want to tell me that you don't know what you're talking about, sir, or something like that, because I was speaking with him about artificial neural networks at the time, and then let us train it to identify the major defects in sewer lines. But he worked hard. Actually, we patented that technology. We've used the data from the city of Hamilton. We have a large network for sewer lines. Hamilton is not concentrated, spread, okay? And so we've used that. They were gracious enough to share it with us. We've used it in the training of trained set of artificial neural networks to almost like a medical doctor to identify the defects. Oh, here you have the most common, you have a crack in there, or you have a deposit, or an infiltration, or maybe a cross-section reduction. All of that we're able to, and again, that was a good example of digitalization. You're using digital image plus AI technology in order to come up with something useful, okay? Maybe for civil engineering, this would be more ready. Bridge decks, reinforced concrete bridge decks, and what is the condition assessment of that? So we've used digital imaging again, but also with infrared and GPR. GPR stands for ground penetrating radar. And but almost the philosophy behind this is almost like you're going to a medical doctor, and before he diagnosed you, he will say, and then open your mouth. Okay, look at here. He gauged the blood, he had the temperature, and maybe he's asking you to do a urine test or a blood test. And then at the end, he would make a diagnosis. So from various sensing and various sources. So we said, okay, we're going to do the same thing on a bridge. We are the doctors here, and we're going to see the condition here by looking at the digital imaging. We're looking at the infrared, and this is exactly what happened. And by the way, that deck was about to be replaced because it was deteriorating, but the testing before they removed it. And again, a lot of people, students also worked on that later on, including this fellow was an able mathematician, a top-notch engineer with an eye on mathematics. But then for people using GPR, and we get the readings of that, the amplitude, I mean, you could run the test. I will ask Ihab, he will come up with an answer. Jack would probably come with the same data, a different answer. If he asked me, I would come up with a third answer. So he worked very hard to have a standardized amplitude for GPR. So when we look at that test, all of us will come up more or less with the same diagnosis, but then he had a lot of AI technologies in his work in tech analytics to come up with a diagnosis of the interesting for water distribution networks. This is Ahmed Asad. And he looked at the data was collected from the city of London, Ontario, and work on the water distribution system. And the idea here, this is the fellow that developed metrics for resilience. So I told you, what do you mean resilience? Do you have a thermometer to measure resilience? Okay, he did that thermometer. I like these images because I got them from the World Wide Web to explain resilience in a nutshell. Resilience, we have the 3 R's. We are almost on every time we speak about 3 R's. Resistance, now you have a hazard. An earthquake happened, a major flooding happened. So that would disrupt the capacity of the system. You cannot distribute the water as you had wanted. So all of that would fall down very quickly, or maybe in a reasonable, in a gradual manner, and then you have to respond, and then you recover. But imagine if you raise the resilience beforehand, you would be able, after a hazard, at the response time, you did not reach the tipping point. You have an allowance, but then it costs money. How, for example, if I wanted to have a resilience, I just give you an example of a water distribution system. The water is going to this house in that way, but if an accident happened, then I need to make a bypass and have another alternative. Once you have another alternative, you're building something, a redundancy in the system, right? And that costs money. But how much money you're going to pay for how much increase in resilience? That was the issue, and really applied it on a section of the water distribution network in London, Ontario. And his metrics, or his thermometer, has 2 components: robustness and redundancy. Robustness, it means the ability of the system to withstand, the resistance part. If you are hit with an earthquake, don't collapse immediately, degrade, have maybe 50% capacity, not zero capacity right away. And then redundancy as well will come, even if you have degraded so much. We wanted an alternative things. I need to really speed up things. I could see that I would share maybe last slide. I skipped maybe, I think, at the time, because I was told an hour and a half or to an hour, so I've allowed for something like that. But I want to share you with maybe the last one here. Where is that? I wanted to share it with you. Yeah, this particular one, and then we wrap it up with a summary. Okay? Very helpful. Thank you so much. But I think I would have hit that. Oh, great. You could see, I told you, BIM is almost everywhere. BIM, 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 right? Is almost in a recent survey, about 40% of those surveyed using BIM just regularly. I think in Europe, they're much more than that as well. Construction management, you remember the drones, the prefabrication and modular construction. I'm glad that you see it in the upper part of that chart or that table. In other words, BIM would be maybe twice as much using compared to blockchain or maybe augmented reality, virtual reality applications. And with this, I wanted to summarize what we said today. And in summary, we've taken a look at 3 major things in that lecture, apart from my story. Yeah, the part that has to do how projects are conceived and how project delivery systems can be an excellent vehicle to tell us what will be the best way to deliver this project. Okay. The second one was what are we doing in order to meet the target that Canada set for carbon emissions by the year 2050, almost 0 carbon, and even in the year 2030, which is, as I said, tomorrow, reducing the carbon emissions at the level of 2005 by 50%. What are we doing? We've shared some of the stories on that. And the last one was automation and digital transformation. I want to leave you not only about technology before I wrap it up. It is people, people, and people. And this means we educate people well in universities and we mentor them well. And also we have to look at an invitation, frankly and seriously, into our curriculum in civil engineering. What needs to be updated, what needs to be considered, how could we align it with the need as we proceed. with that, thank you all very much for your attention. I will wrap it up. Thank you.
Thank you, Dr. Moselhi, for that very enlightening speech or lecture. We have a short time for questions and answers, and I would like you to take, please rise at your seat, ask a question for Dr. Moselhi to answer. Be brief and focus on your question. Now you have to speak loud enough. If you can't, then I'll bring the microphone to you. So please, anyone who wants to ask a question, please raise your hand.
People need the microphone to hear the question. Any questions? I'll run to you. Yes. We have people online, so they need to be able.
Do you really think we're going to reach the target?
Do you really think that we're going to be able to reach the target?
You know me, I am an optimist. For sure, we're going to approach the target. Always set targets for yourself. The people when they compete in Olympiad, and those who would win the first prize, you know, they have to think that their mindset, as I was saying in circular economy, the mindset is very important. Yes, I believe, in my humble opinion, that yes, we will achieve these targets. And Canada is a leader in environment and will continue to do so. And I would like governments that would support that direction as well. I'm not wanting to be a politician here or talk about politics, but we really need funds, as I said, to support research in this direction and assume leadership.
Do you think AI could ever replace engineers entirely, or at least large chunks of their work?
This is a big question, and frankly, from what I have seen and heard and read, I cannot say yes and I cannot say no. People think, oh, as long as we're programming things, we are in control. No, with Gen AI is no, they are correcting themselves, and they need not us to correct them, and we need. So in my humble opinion, all what we need is really to put policies and regulations for the use of AI technology and any other technology. In my humble opinion, technology should be subservient to humans, not the other way around. But your question is very important, and people talk about it, and even specialists in the field of AI are warning themselves, they're warning government, control us in a certain way. So controlling it does not mean that you suppress and eliminate innovation and advance. No, we have to make sure that at the end of the day, we are serving human beings, not the other way around. But if we leave it without control, we could be in trouble. And how many of you are using have you seen a chat GPT and yeah, okay, so here you are. Yeah.
But I kind of looked into that, and we were looking at ways to, like, for new additions to our civil engineering curriculum. So AI always comes up. And AI, you know, you just think of chat GPT, you just dump in some words and then it spits out something back to you. But there are optimization AI programs in the field already for civil engineering, for building optimization, cost optimization, energy optimization already. So, I mean, it's just going to get better and better and better.
AI, as you've seen in the example that I gave you during construction for the images on site and recognizing that this is the duct work, and all of this is AI plus other images from other technology. So AI, if you utilize it well, it will definitely, but it will continue to be part of our life, and particularly for young aspiring engineer. Absolutely, this will impact your life moving forward, whether you like it or not. So we have to have the training, and we need to branch into more multidisciplinary stuff. Let us not work in silos where I know my stuff and I don't want, and you do your stuff. And no, we need to integrate Remember, when we say automation and integration, we need to integrate and we need to learn from one another in various disciplines.
Any other questions?
So I guess with the advancement of microcontrollers and microsensors and how cost effective they're becoming, do you see that as a way forward for us to elongate the lifespan of structures and in particular to target rehabilitation efforts on deteriorating structures?
Kindly restate your questions.
So I guess my question is, with the advancement of microcontrollers and
Yes.
sensors and Arduinos and how cheap they're becoming now,
Yes.
do you see that as an effective method to elongate the lifespan of structures and in particular to target rehabilitation efforts?
Absolutely. Yes, and yes, and yes, and yes. So the answer is yes, and yes, and yes. No doubt about it. And also, the technology is becoming affordable now. In the past, it used to be only on nuclear power plants where the instruments certain things for. At the time, even the word structure health monitoring was not known, but we know in order to know the conditions with time. Now, in bridges, companies now, when they do in a PPP and they construct a bridge, like what is happening in Montreal, the recent one that we put in, people are build, own, and operate. My goodness, whatever I'm building, I have to operate it, so the maintenance cost has to be within control. So they have instrumentation, they have the field of data analytics to help you out. This is going to crack soon, beef up that section before. It's very sad news today. I think if you read what the news, the bridge that collapsed in the States today. Yeah. And I don't think what we said here can because unless we know what happens really, but human beings will continue to make errors, but also we're smart. If you look at thousands of years ago, we're definitely improved. So with all of our, failings, we also continue to succeed and continue to get. So the positive is by far more than the negative in what we progress.
Thank you. Thank you, Dr. Moselhi. That was remarkable. We are indeed grateful to you for accepting our invitation to deliver the 2024 John Adjeleian lecture and to share with us some of the remarkable work that you and your students have done in the areas of delivery and construction and management. I'm glad that you fell in love with academia, because that allowed the students to work with you and to produce such remarkable work. You are in competition here. Of course, there are a lot more people here who are in love with academia. So now at this time, as a token of our love for you, for your lecture, I will invite Banu Armachi, our chair of the department, and Mr. Professor Ahab Izalog to make a small presentation as a token of our appreciation, please.
Thank you. I was delighted to be with you today. Thank you so much. Thank you so much. So much.
Over the years, and in particular during the last few years, many young faculty members have joined the Department of Civil and Environmental Engineering in our university. And they have made remarkable achievements and achieved new milestones in research, teaching, innovation, and have won accolades for their work. It is therefore only appropriate that we honor these high-achieving faculty members. I'll be grateful if the department chair, Professor Banu Armachi, would help us in recognizing the distinguished faculty members. Manu.
Thank you so much. Do we have the slides, please? Yes, the one. So we have an outstanding department, truly. I happen to be the interim chair this year, and I'm a researcher. I'm a researcher, Jostowski research chair. I was previously a Canada researcher. I do a lot of research. I love teaching. I love mentoring, and I know the field. And our department is truly outstanding, which I really mean this. But I think one of the things that really sets us apart, I mean, there's some universities, and I can say this for Carleton University as well. Um, Research is important, but research is not everything for us. So education, teaching, our undergraduate students, graduate students are at the top of our priority list. And we also do a lot of mentoring. And I think that's what makes us excellent overall. So when the slides are coming up, oh, okay, they're coming up, okay. I just wanted to say a few words. Our department is also very unique. We're not just a civil engineering department. We have civil engineering, environmental engineering, and architectural conservation and sustainability. And following on your talk, like the points that you made, the importance of circular economy applying to civil engineering, sustainability, energy efficiency. So we do have full programs in environmental engineering, architectural engineering, sustainability, which we have all of those components in our curriculum, and that's really going forward, looking forward. That sets us apart because we already have that expertise in fully established programs. Okay, so I was asked to give you a quick summary of the achievements of the faculty members. And I looked at it like, oh my God, what am I going to do? How am I going to do this? We have 40 faculty members. We hired 12 faculty members after COVID happened, which again is unique in Canada because most universities or departments, civil engineering departments shrank. And they're all excellent, outstanding researchers. I happen to be in this position, signing on all the budgets. I see the amount of research funding people bring, and it's truly millions and millions and millions of dollars. So there is not enough time to list all of those, all the projects, and there are also career awards, international awards, and again, 40 of us. So it's really difficult to do this fairly. I just wanted to say that we kind of decided to focus on the recent awards, and particularly Carleton University awards that are also focused on teaching and mentoring. Okay. So we have 2 new Canada research chairs in our department. So Canada researchers are emerging outstanding researchers. They are the future stars in their fields. And Canada Research Chairs is basically approved, given by the federal government of Canada. And so these are truly exceptional researchers. And we are very fortunate to have 2 of these Canada Research Chairs in our department, all recent hires. Professor Jennifer Drake, she works on stormwater and low impact development. And the importance of that is after climate change, everything has changed. Is it all like the rain events, weather events, the amount of stormwater, and it comes like a flood. Our current infrastructure cannot really handle those large stormwater flows. And so Jennifer has a different approach, low impact development. So again, working with nature, working with simple systems that basically allows this stormwater to be absorbed by the ground and earth, and so there are definitely alternative ways to do this, and this can be done in an environmentally friendly way, in a very efficient way. You don't need to invest billions of dollars in huge pipes and infrastructures. So Professor, is Jennifer here? I don't think so, but Oh, there is Jennifer. Okay. I cannot see everyone. It's a big group of people. So there is Jennifer. Hi, Jennifer. And our second CRC Eli is also here, sitting right in the front. So I can see him. Okay, so Eli's area is also very interesting and also again related to sustainable buildings, communities. So these are really hot fields. And Eli works with a very strong research group as well. And his area of expertise is mostly on the building side. And we are very happy to have them both in our department. Okay, so we have two more stars this year. So every year there is kind of a ranking, international, that ranks the top researchers in their fields based on citations, based on what is a citation, based on how many people refer to these researchers. And so we have two stars in our department who basically are in the top two in the whole world in their fields. And these are Professor Yasser Hassan and Professor Liam O'Brien. And so we are also very proud to have them. So these are the more senior faculty members. Okay, so achievement awards, Carleton University has achievement awards on research excellence, teaching excellence, and also service achievement award. So Professor Bucking and Professor Hussein, they received research achievement awards this year. Professor Bora Platso received the Teaching Achievement Award. Bora was here. Abidan Scott. Bora is in the back somewhere helping. Okay. And also Professor Shule Shams received the Professional Achievement Award. And I would like to say that there are 10 of these awards in each category. And our department this year got 5 of them. I mean, that's a very high percentage. So this year we also focused on teaching, updating our curriculum, including all these new innovations, new ways of teaching, and their budget cuts too. So the university has some funding opportunities that we can use for teaching, to update teaching or introduce new initiatives. So Future Learning Innovation Fellowship is one of these opportunities. Professor Bucking and Professor Drake got 2 of these. Next slide, please. And also, last year, Professor Gilmore and Professor Hassan got 2 of these fellowships as well. And so we use these fellowships to introduce, for example, new technology, new software, AI, all of these new developments, and incorporate those in our program. The other opportunity, again, I kind of want to emphasize the teaching because it's dear to our heart. And the other opportunity is the Carleton University Experiential Learning Fund. So learning is not just, reading textbooks, but it's doing it, applied learning, real world problems. And so the Experiential Learning Fund are funds provided by the university, again, very competitive. But it does provide us the funds to make these really innovative changes to our curriculum, introduce new courses. And so we have 3 successful recipients, Professor Zobolotny, Professor Platsu, and Professor Drake again. As well as Professor Basu and Christian Via. Okay, so one more, and this is also again Carleton funds for purchasing teaching equipment because we don't want to keep doing the same labs over and over again. We want to change them. We want to introduce our students to new labs. And so these funds are typically used to purchase new teaching lab equipment or other, again, hands-on activities. And this year we had 4 of these, which was, again, the highest. I mean, I think we were the only department who got all of these funding opportunities in that round. And so we are all very happy. And the reason I picked these awards, again, there's so many more, I cannot list everyone, but it just shows our commitment to not just research excellence, but also teaching and mentorship excellence. And so we're making really impressive changes to our curriculum and updating the engineering curriculum. As again, our speaker indicated that engineering curriculum nationwide requires changes. Next slide. Okay, so some research studies, again, so difficult to pick this. And I said, okay, like, let's just focus on the stories that are in the media right now. So like these are in the last few weeks. You might have seen this research. Professor Sean Ken it was on TV a lot, on the radio. People like this kind of research. But his team basically built these snowbots that optimize the ice growth on the canal, on the skateway. And so this can be a fleet. And so this is really helpful, particularly, again, during climate change, where we do not have as cold temperatures anymore. So this received a lot of media attention. I was in the gym a couple of days ago. It was again on TV. So yes, next slide, please. So this is now today on Carleton's website. This is also Professor Drake's research, working on alternative ways of stormwater management, especially, again, climate change. And what you see here is what is called the green roof. So that absorbs, all that stormwater, and it's an environmentally friendly way of managing these peak flows. The last one, does it play? There should be a video there. Next one, maybe. Is there a video there? No? Maybe that. So my okay, so these are, I'll explain you what they are. So these are shaker tables. They are enormous. This was a CFI project, and it took a lot of time and commitment from Professor David Lau and Professor Jeff. I mean, they spend a lot of time on this. Are we getting the video, or I'll just, oh, there it is. There's a click. Fingers crossed. So Professor Jeff Erochko and David Lau are the masterminds behind this. You don't have one of these, do you? No, of course, I know you don't because this is the only facility in the world, as far as I know, and we're not exaggerating here. So this is a really unique facility, and as you can tell, it is used for earthquake simulations and the building responses. So there's lots of really interesting research that can be done with this. And I think I've spoken enough. I'll stop here. Yes, you can be jealous. Thank you. Thank you. And I'd like to thank everyone and thank our faculty.
It was great to see such achievement, and the department's really proud of it, and kudos to all of the faculty members. I was once a faculty member in the same department, so it makes me extra proud to be associated with the department. Now we go to the last few items. It's been a tradition with us to use this opportunity to honor those of our graduate and undergraduate students who excelled in their academic work, and by giving out the awards they have earned in these years. I am pleased to invite Professor Jeffrey Rochko, the supervisor for graduate studies in the department, to make these awards.
Thank you, Jag. Okay, well, as Dr. Armici alluded to, we do a lot of great research here, but I always say that the biggest impact that we actually make on society is all of the graduates from our program who go out and work. We have a lot here. We have some recent graduates. We have some former graduates who are now in graduate school. We have current graduate students who will be future graduates who are going to go out and do really great things. So it's really my pleasure to be able to be here today to celebrate the work of our undergraduates and graduate students. I'm joined by Professor Paul Van Giel, who is the other Associate Chair, Graduate Studies in the department. And I'm going to give some brief instructions because we have a lot of awards because our students are extremely, extremely spectacular in getting all of these awards. So we'll have to keep things moving a little bit as fast as we can because probably everybody's getting a little bit hungry. We have some refreshments after. So what I'll ask you to do when we call an award is to come down at the front. We have all of the awards right here. You'll come to the front. We'll announce your name. Well, I'll have to announce your name first, I guess. Otherwise, you won't know to come. I'll announce your name. You'll come down to the front. Dr. Zolak is here. He's going to take a picture. So just come to the front here. We'll take a quick picture, and then we'll have to move on to the next one. I'll give very brief comments about each. So if we're ready, we can get started with the first one. And for this, we have some guests to help us present the awards. It is Ainsley Griffin and Fadi Dow from Adjeleian Allen Rubelli Engineers, who we heard a lot about earlier, to present the Adjeleian Allen Rubelli Prize, which goes to the students who had the best fourth-year capstone engineering project of the previous year. And those students are sitting right at the front here. Zachary Beltrame, Samuel Hurd, Mariam Nabi, Susan Old Brahim, and Brendan Devine couldn't be here. Congratulations. I'm actually a bit biased because together with Dr. Sadeghian, I supervise this group. Not that I'm taking credit. Zach, just come. Thank you very much. Thanks. Yes. No, it's actually, yeah. For the next award, I'd like to ask Michael Adjeleian to come down and present. This is the John Adjeleian Undergraduate Scholarship, which goes to an outstanding graduate student in the area of structural design. And this year's winner is Anthony Urbishi. Very much. The next award, the recipient is not here, but it's the Guhar Shemden Award in Built Heritage Conservation for outstanding undergraduate student in architectural conservation and sustainability, given to Rami Darwish. Next one also unfortunately couldn't make it today, which is the Luigi Mion Scholarship in Engineering, given this year to Noah Stoute. The next award, the Gunther and Irmgard Bauer Scholarship in Civil Engineering, is for an outstanding undergraduate in civil engineering, endowed by a generous gift from our own Professor Emeritus Gunther and Mrs. Irmgard Bauer. And this year it's going to Tolu Wanimi Tella. The next award is the Robert Pickard Scholarship in Environmental Engineering. This award is for an outstanding, actually in this case, 2 outstanding full-time students who demonstrated interest in problems in environmental engineering, endowed in 1990 by the colleagues, friends, and family of Robert Pickard, Commissioner of Environmental Services for the Regional Municipality of Ottawa Carleton. Sorry, this is a long list here. And this year is for Anjali Mohammed and Delaney Chung. All together, it'll be, yeah. Very much. Our next awardee couldn't make it, but it is the Verid Foundation Scholarship that goes to one outstanding engineering student in civil engineering for Samuel Pierce. The next scholarship is the Abdel Halim Scholarship, named after our former chair, which was endowed in his name, which supports an outstanding graduate student entering or continuing a program in transportation engineering. And this year's winner is Jalal Bardzagaran. Okay, the next scholarship is the Alfred J. Wise Scholarship, which is for outstanding graduate students entering or continuing studies in fire safety engineering. Alfred J. Wise was one of the founding members of the Montreal-Ottawa chapter of the Society of Fire Protection Engineers. And this year's winners are Kambiz Deneshvar and Saba Syed Drazavi. I told you that our students are very, very accomplished. The next award is the Atacon Sustainable Transportation Graduate Scholarship, which is named and endowed in the name of Professor Atacon, who's a retired professor of our department. He might be online right now. And this is for outstanding students in transportation engineering, studying sustainable transportation. And this year's winner is Mitchell Lawler. Okay, actually, the next 2 awards are for the same student, so I'll get you to stay up here when we do it. The first is the Batter Student Travel Award, which is for graduate students demonstrating an interest in traveling away to present papers, attending conferences, endowed by Alfred and Isabel Batter in recognition of their belief in the importance of research travel and international exchange of ideas. And this goes to Rula Al-Haidari. I think we can do the one, but stay here just for 1 second so we can give you the next award, which is the Bill Hirsch Memorial Scholarship for an outstanding female graduate student enrolled in engineering, endowed by Lyra Shapiro and the late Bill Hirsch, 2004. Here you are. Thank you. Oh, we'll do the other one. Those pictures will more or less look identical. Okay, the next is the CEE TA Excellence Award, which is awarded annually to 2 teaching assistants who've been nominated by the students of our department for their efforts and excellence in helping students to understand the concepts and solutions conveyed in lectures, laboratories, and problem analysis sessions. And last year's winners of this award were Wamid Al-Ghazala and Rhea Wilson. Yep. Oh, great. Let's do it all together. Okay, the next awardee couldn't make it today, but it's the Charles Shrubsole Graduate Scholarship, which goes to outstanding graduate students specializing in the field of transportation, endowed in 2021 by the Shrubsole family in memory of their uncle. And this year's winner was Salah Fakouri. Next is the Gordon Shields Memorial Scholarship, which is for an outstanding graduate student enrolled in the Building Engineering Graduate Program, conducting research related to renewable energy, net zero energy, or high performance buildings, endowed in 2018 by Milfred Hammerbacher in memory of Gordon Shields, who was one of the founding members of the Net Zero Energy Home Coalition. She couldn't make it tonight, but her name is Hannah Villeneuve. The next award is for students who did our undergraduate program and then went on to enroll in the graduate programs in the Department of Civil Engineering. And we have 5 recipients this year: Ava Bebbington, John David Clarabet, Aya Hassan, Isaac Rudnicki, and Hannah Villeneuve. And Aya Hassan is here. Congratulations. For the next award, I'd like to invite Dr. Jaghumar to come to the front again, because this is the Jaghumar Graduate Scholarship, which was endowed in 2003 by the family, friends, and colleagues of Dr. Humar. Upon his retirement, to recognize his contributions to the university, the profession, and the community. And this is for a candidate that demonstrates outstanding academic achievement and the ability and desire to assist undergraduate students of engineering in their studies. And this year's winner is Peter Bergheis. For the next award, I'd like to invite Mrs. Adjeleian to come down to the front. This is for the John Adjeleian Graduate Scholarship, which is awarded annually in alternate years to engineering, civil engineering, and architecture, knowing how Dr. Adjeleian straddled both fields. And this year, the recipient is from architecture, and his name is Jerry Raphael White.
strongly here.
Would you like to say it in the microphone?
Well, I just wanted to say how happy my husband would have been to be here.
Thank you. Okay, next we have the John Braxma Transportation Award, and awarded annually to a graduate student working in the field of transportation engineering who demonstrated work experience in the broad area of transportation and shares Professor Braxma's philosophy of people-oriented focus on transportation engineering. And this year's winner is Rula Al-Haidari. That one I hope is also a little bit different. Yeah. Next is the John Ruptash Fellowship, which was established in 1974, a longstanding fellowship by relatives, former students, and faculty colleagues of the late John Ruptash, who was Dean of the Faculty of Engineering. The fellowship is awarded annually beginning in 1975 to an outstanding graduate student in the faculty, and this year's winner is Carolyn Bitter. You're getting so close to my, I feel like you're getting really close to my face. The next is the Kochar Family Scholarship. This is a scholarship that is specifically for outstanding international students from India to encourage India-Canada cross-collaboration in civil engineering, architecture, or urbanism, created in 2013 by generous donation by Kuku Kochar, in loving memory of his mother and grandmother who strongly believed in the legacy of higher education and lifelong learning. And we had two winners last year, and this year, Jiva Subramaniam Kumar and Mirza Mohammed Beg. Thank you. Okay, next we have the Marie Carter Memorial Scholarship, awarded to outstanding graduate students in engineering, with preference given to female recipients who promote women in engineering. And this year the winner is Santina Green Minyaka. Oh, yeah, you can stay up here, yeah. And another frequent flyer. So the next awards are national awards and provincial awards that are that graduate students apply for, and they compete with all the students in the province. These are very prestigious scholarships in the tens of thousands of dollars. And we have NSERC awards, those are the national ones, and we have OGS awards. And this year for NSERC, we had one MASC student win the award, who again is Santina Green-Minyaka. And we also had a PhD candidate win one of these awards, Andre Marcus. We have fewer ahead than we have behind, so we're getting through. The next is Ontario Graduate Scholarship, which is a provincial kind of equivalent to NSERC from the Ontario government. And this year, three winners were Peter Bergheis, Carolyn Bitter, and Brody Hobson. That one is, that one's Brody. No, I just only have two hands, sorry. Actually, check. Okay. Open Graduate Scholarship is one of the university-wide scholarships that a student compete for every year based on basically academic achievement. And this year we had two winners, John David Clarabit and Milad Rostami. In addition to having department-specific TA awards, there is also a university-wide teaching award for teaching assistants. And last year, we had one student who had an honorable mention. Again, this is across the entire university, so I think there's only a couple winners and a couple honorable mentions, and that was Farzam Settana. Sorry, I'm going to say your name again because I definitely got it wrong. Farzam Sepanta. Okay, hang tight. Thank you so much. Farzam also received an OGS, but somehow slipped off the list here. The next scholarship is the Pavel Kaleb Scholarship for outstanding graduate students in civil and environmental engineering, endowed in 2020 by Pavel Kaleb. This student also, you saw the shake tables. This student is basically solely responsible for those shake tables operation. His name is Cameron Flood. Next, we have the Queen Elizabeth II Scholarship. This is a provincial-wide scholarship for students in science and technology. It's kind of similar to OGS. And this year's winner was Elise Hamp. I'd like to invite Mohammed Muradi from the Society of Fire Protection Engineers to deliver the SFPE, Society of Fire Protection Engineers, and what's NCC in this? National Capital Commission. Fire Safety Engineering Award for outstanding graduate student in the area of fire safety engineering. And this year's winner was Saba Syed Drazavi. And that was the final award. Maybe an overall round of applause for all of our students. Thank you very much.
Thank you, Jeff, for running through the list. It's a long list and it's such an honor. And you did it very well. Now we come to the end of our conclusion of this evening. I will invite Professor Ehab Zalok to deliver a vote of thanks. Ehab was the chair of the Adjeleian committee which put together this whole program. So give a round of applause for Ehab. There are a number of other people who are involved in the organization, and Ehab is going to recognize all of them. So I will leave it to him to do the recognition.
Thanks for coming to, today. That's sort of a nice conclusion to the work of that committee that started, beginning of this academic year to look into the best speaker possible in the area. So thanks for all the colleagues in the committee. I'm very bad at names, but I know Ray, she did a marvelous job. And then next to her at the very, very back, Professor Bora, that very nice picture that we saw early on with so many awards this year. And Adam Weiss and also Jack Vanderberg. Oh, Jack is there. Thanks, Jack. And everybody who contributed to this one as well. Thank you. And I want to invite people for food. Time to eat.
So we have food. I know you have been so patient sitting here. And we have some refreshments, some food as well, not just refreshments. In spite of the budget cuts, we splurged a bit. So please help yourself and thanks for coming again. Thank you.